Hey guys, so today I'm going to be showing you how to make the Drawbot for the popular painting game, or, you know, the Roblox replicas, the many Roblox replicas that it has. So if you haven't checked out the demo video before watching this, then please do that because you probably want an idea of what the final product is going to look like. So yeah, let's get right into it. And all you kind of need is Python installed on your computer, and preferably VS Code, which I'm using so that you can follow along with less issues. And all I have right now is a blank folder. So yeah, we're doing this completely from scratch. So let's get right into it. And I do like to install my modules in a virtual environment. So I think it's a good idea to do that here as well. So I'm gonna open up my terminal here to be able to create a virtual environment. So you can go ahead and type this in with me. Um, Oops, that's the wrong um, command there. We're already off to a great start. I think that should be better. And yeah, this is gonna be quite a marathon of a video because um, it's quite a long program compared to anything I've done before, but I think it is more rewarding at the end as well because the result's pretty cool. So yeah, we kind of have this virtual environment thing here, and then next we want to select it. So um, we want to select the interpreter here to this, and let's activate it in our terminal as well. So you can just copy down whatever I'm typing here. My PC shut down when I tried to click the A key. Um, so yeah, I don't know what that's about, but hopefully that doesn't happen again. But yeah, now we are in the virtual environment after running that thing, which is good. And by the way, if you saw the video, you probably saw like the little user interface that we had. You know, the little hacking device, and yeah, that we made that using Tkinter, the module, which basically allows you to make stuff like that. And we are going to be using that for the tutorial, of course, as well. And that basically just lets you create the user interface and add buttons and, places where you can type things in and all that. So yeah, to get things started, let's just create a Python file, of course. So to just lay things out, let's create the two Python files actually that um, we're gonna have for this. Yep, my A key works now, which is a good sign. So app.py, as well as um, kind of just a drawbot, which is gonna have the more juicy code in it for drawing. And those are going to be the two files we're going to be working with app.py being the main thing. And we are going to have a few more things that I will add on eventually. So yeah, let's start with Drawbot because that is the main thing that we are going to be coding. So we need quite a few modules for this project. So let's just start by importing them, and as we do that, I'll be explaining to you guys what they are. My A key still isn't having a very good time, but hopefully that gets resolved soon. Yeah, before we move on, I'm just going to stop and tell you what I'm doing. So, if you're wondering, C types is basically like what allows us, the Drawbot's mouse and keyboard, to send commands to Windows, which, well, just as a disclaimer, I'm not really sure if this code would work for Mac. I presume it wouldn't. So, yeah, um, you should probably do this on a Windows if you're trying to follow along. So yeah, C types helps with that. And then JSON basically allows us um, to store settings. We're going to have a JSON file later, which is going to save our settings for our app. Because we're basically creating an app right now, and we want to store our settings that the user puts in, such as like, the delay time and all that. And math is basically just allows you to do different math things. We're going to be using it to, resize images and deal with colors and stuff. And then struct is a module that allows you to do the resizing calculations, because you're gonna be dealing with different images. Okay, I don't need the backup there. And then threading is basically what allows us to send commands between the interface and the executor. And then time just lets you do things like wait a few seconds and things, which is pretty useful, as you'll see later. And then from collections, we're importing counter. And counter is basically an important thing that we need to be able to order the Drawbot colors by the number of pixels they occupy. So all this will make more sense as we go on. But to just finish things off, data classes is it basically allows us to create things like data containers, which can store things. And yeah, again, all of this will make way more sense when we put it to use. I think it's better if we do it that way. So there's just a few more modules that we need to import. From. And we also need pillow, which I think we will need to pip install in a second here. And I know this one here looks kind of interesting, but yeah, pillow basically lets us do the resizing of the images and recoloring. And also, if you watch the video, you'd see that we can freehand select images and stuff on the screen. So yeah, it's quite useful for that. So let's just pip install pillow first. And I think that should resolve the underline there soon. Yep, there we go. And yeah, now we can move on to the main things. Now, if you've watched my previous tutorial videos, you probably know that because we have two py files, one of them is just going to have different functions and things, and the other, which is app.py, is going to be kind of our main.py, which is actually going to be running. So yeah, this one's just going to have a bunch of different functions, but yeah, it is the main thing that kind of lets our Drawbot function. So next, we kind of just need a lot of we need to define the Windows mouse flags for the cursor motions and the mouse presses, like pressing the up key and the control key and the A key and the backspace, enter, and all that. So yeah, it is a bit tedious, but we need to do this for quite a few things. I just realized I forgot the F there. So yeah, basically, these are kind of codes for each key, like key up and control, and well, the A key and the escape key and all that. So yeah, it is a bit tedious, but we're gonna type all these out. So yeah, just to explain what's going on, this is code for the shift key, this is code for the escape key, that's the code for the Q key. So yeah, once we have those, let's move on to something slightly more interesting, I suppose. So yeah, we're gonna be using data classes for this project, which I believe we didn't use for the previous two videos that I had. So basically, a data class allows you to have um, different variables and kind of link them together. So let me just write it down first. So basically, what we're doing here is we're generating a point object which um, stores the Drawbot screen and image coordinates. And also here, X and Y is just the horizontal and vertical screen coordinate. And this time we're going to be, as you probably already noticed, we're using object-oriented programming because we have that class there. So here we're going to be creating another object called preset. And for preset, we're going to be using it to store things like canvas bounds that, as you saw in the video, we can freehand select, and also the hex field point coordinates. So yeah, I just put an arbitrary coordinate here for where the hex input should be, but then this is going to be overridden once we calibrate the hex coordinate, as you saw in the video, probably. And if you're wondering what this is, before, there's kind of two ways you can go about selecting the canvas. So one of them is you can select the top left and the bottom right, and then, well, of course, everything between the top left and bottom right are going to be counted as the canvas. But then this canvas mask is another way which we're going to be using for this video. But you can always switch back to top left and bottom right, by the way. But then for this video, we're going to be using canvas mask, which allows you to freehand select the canvas boundary. And this line of code here basically allows you to trace out the paintable canvas boundary. So yeah, if you notice here, we're using point, which basically calls back to this object that we created here, which allows you to have a point on the image coordinates. So yeah, I think it's pretty cool how you can already see these linking together, and hopefully the code makes more and more sense as we go along in the video. So now we're creating the settings, which some of them have default settings that we just need to write down once and they don't have to be changed later. But then some of the settings we want to be able to change later. So yeah, we'll deal with that later. But right now we're just creating the variables for the settings. So yeah, I just have it as Roblox for now, but it really doesn't matter. You don't even kind of need this. But yeah, just in the future, if you want to save multiple different kind of presets of settings, then you can have that. But then right now we're just having one, which is Roblox. You can name it anything you want. It really doesn't matter. So image path is basically where the image is going to be stored, and what location, file location, and distance is the pixel distance between different clicks, and one gives the best results, but if you decrease it, your code would run faster, obviously, but you would also get worse results. So yeah, since the focus of my game was not making something that can actually, make you win in public lobbies, you can keep it as a high setting like 1, because that would give you better drawings, of course. So here's a few delay um, variables, and you can tweak with them as much as you want. I have all of these at a very low setting, some of them even 0, but sometimes your code doesn't seem to work, and if you increase the delay, perhaps because you're clicking or doing actions too fast, so yeah, if you increase the delay, perhaps it can work then. So yeah, that's why I have these settings even though they're set at 0. So fast is basically just a fast mode, which I'm going to be having true the whole time, but you can tweak the code and make it false so that it doesn't use fast mode. But yeah, for right now, we're just gonna have it true all the time because it gives pretty good results, and also significantly boosts your um, time of drawing. I know it's already quite slow, but it can get even slower. So yeah, I think having fast mode on all the time is a good idea, but just because you might want to turn it off, I have it as a setting that you can always set to false. So here's another setting that I've optionally added, and basically if you get rid of this, if you make it, I mean, you don't get rid of it, but if you make it false, then it has the risk of drawing unwanted horizontal lines just because of how the program operates. So if you have safe strokes as true, it basically minimizes how much that happens. So yeah, if you want to speed up your time, I think you can set it to false. That's why I have it as a option here, but we're just gonna have it as true by default. So hex color count is quite intuitive. It's just how many colors it's gonna try to draw the thing with, because a picture that you take a screenshot of can have like a million colors in it, but um, your eye can probably not even detect um, between most of them. So something like 12 colors is usually good enough for like um, the painting games that we've been playing, because they draw something good enough to have you camouflage in. But yeah, this is going to be an adjustable setting in our app. So if you want to draw things with more colors, you can, with of course the trade-off of it taking more time to draw. So here's another optional setting that we really don't need to change, but yeah, the way um, the image fits on the canvas is just going to be fit, and you can add more ways to fit, like I don't know, stretch or something, but then um, that is more work, so we're just going to have it as fit the whole time. So transparent color is basically like if you have an image with um, transparent pixels. So you know those PNG images with transparent backgrounds. So basically just wherever it's transparent, and just type, it just paints it white, which I think is good to avoid errors and things like that. So yeah, that's the end of this data class. We can now move on. So Instruction is going to be the action that is performed when we finish the drawing plan which the program makes. So it's basically just like a test mode that ensures everything works. So yeah, let me just type it out and it'll explain. So kind is basically the kind of, drawing action it does. So we're going to have this later, but dot is going to be just one dot, one dab. And dot run is going to be a series of dots, while drag is going to be like a held, you hold your mouse and draw a line. So yeah, we're going to deal with this stuff later. And points is basically a tuple, which is basically, if you know what a list is, then a tuple is something similar. And this tuple is going to contain the screen positions that are used in that action. The action is going to be determined by the kind of action is being determined by kind, but points is what has the positions, the coordinates, and color is just the color, the hex color. So yeah, now we have draw plan, which is basically, if you watch the video, you'd see that there's a preview plan button thing that you can click, and then it displays a preview of what it's going to try to draw. So if you have 12 colors, it's going to try to redraw that image that you've uploaded with 12 colors. I mean, not upload it. I mean, you could upload an image as well, or you can take a screenshot of the image. So the image is going to be the same as the Drawbot preview thing that we see on the right, and it's going to be a resized and reduced image of that, obviously, because we're using 12 colors and things like that. So let me explain what's going on here. So instructions is basically, it calls on this instruction thing. So it does some actions. And color order is the order of colors which will be painted in. So, you have the you have different colors that the image consists of, and it goes one color at a time. So color order just determines that color, and usually it's just going from least to greatest in terms of the hex. And palette is a list of all the colors that are extracted from the image. And then offset is it basically just records where the fitted image sits inside the larger canvas, rectangle, or the freehand canvas. So within this class, we're going to have a function, and we're going to have this property thing, which basically makes the function run every time the plan mark count, which we're going to have later, is red. And this basically allows it to run every time without us having to call it every time, which is quite useful. So basically, we have this mark count thing, which plans the paint mark total, so how many strokes or marks are going to be in total to paint the entire thing. And yeah, this makes sense when you look at draw plan, because we have that plan and it tells you how many strokes and everything it's going to take. So this is what it does. And if the instruction kind is dot run, which if you remember we talked about just a while ago, then it's going to just count all the different points it took to create the preview image. And then otherwise, it's just going to be 1. And now we can return the total. So that's the output of the function. So yeah, let's move on to just a normal function called color distance. And this is not inside a class, by the way. Also, before I move on, if you're not familiar with what self means within a class, it basically just it's the draw plan itself's instructions that will be counted. So yeah, that's what a self thing does inside of a class. And if you need some more help with kind of these fundamentals, like what self is, then I'd recommend you to just do a quick Google search. So yeah, what we're doing here is basically this function is going to return the RGB distance that's required to match the original image's pixel to the nearest palette color that we have. So if you remember before, we have a list of different palette colors, the 12 palette colors, and obviously the original image is going to have more than 12. So this is going to calculate the distance between the actual color and the 12 palette colors we have, and then accordingly be able to select a color between the 12. And if you're wondering what left and right are, it's basically just the two RGB triples that are being compared. RGB has 3 values. That's why I called it a triple, because red, green, and blue, of course. So yeah, left and right are basically just the original and the one of the 12, and it compares those and sees which one has the least distance, so that's the one it can pick. So yeah, it's the squared difference between left and right, and that's pretty effective way, I think, of um, determining which color is best for that position on the original image. So yeah, let's go move on to another function. And this basically deals with loading presets that we're going to have in a .json file later. So .json file again, I already said this, but it allows you to store settings even after the program is closed, which I think would be useful in this case. So here we're just gonna allow, we're just gonna make sure there's no errors when we don't have anything. So what this line does is it reads the JSON file as a dictionary, which is, if you don't know what a dictionary is, it's just basically another data structure like lists or tuples. And it treats it as an empty file with no calibrations. So yeah, we're basically just making this for loop to be able to fill one calibration value at a time. And right now, this is going to be given error because we don't have point as a function yet. So let's go ahead and write that down. Just before I do that, let me just go ahead and explain what's going on here. So basically, we're saving presets here, and here's where we're loading it. But top left and bottom right are basically the coordinates of the top left, and bottom right. But again, we're not using that. Instead, we're doing a freehand selection of the canvas. So that's why we have canvas mask, if you remember from before, for the freehand selected region. And hex input is again the coordinate. This is arbitrary and it's going to get changed when we actually use the program. But again, this is the coordinate of where the hex input should be on the screen. But yeah, to get this to work, let's first make point as a function, and point is basically the function point is basically going to help us convert the dictionary value in the JSON file to a point with an x and y coordinate. So yeah, maybe this is going to make more sense after I write it down. So let me do that. So this just again handles errors if not value means if value is empty, then it's just gonna return default, which is the point used when value contains no saved coordinate, and value is just a saved dictionary, or well, it's gonna be none when data is missing, but then it's the saved dictionary. So we're gonna have this as a coordinate with x and y now. So value dot get x default dot x, and also same for y. There we go. And we still have an error here. Okay, we've got canvas.mask, but the name's supposed to be canvas underscore mask from before. So yeah, that took care of that. And not sure why that's. We'll see if that gives us an error later, but I think it's just this one, and then we don't need that anymore. Yep, there we go. So let's move on to the next function now, and there's actually quite a few functions. So yeah, again, this is going to be quite a marathon of a video, so feel free to take a break anytime, and if you're lost anywhere, then feel free to leave a comment, or even just do a quick Google search of if there are any concepts that you don't understand here. So now we have save presets that we're gonna save to the JSON file. This is quite similar to our last, except that there we're loading presets and here we're saving presets. So I'm not going to do much explaining here because logic-wise and code-wise it's quite similar. But here we're just saving the presets. And again, we have another function here that we're going to define soon. And from this, you can probably see why this video took so much more time than my previous ones. It did take quite some time for me to learn how to do these things. And again, it wasn't like I typed all this in myself. I obviously used existing code from people, like for the freehand selection things, because obviously people have made freehand selection projects before. So yeah, I had to understand what they're doing and then kind of integrating it into my own code and kind of get different things. So yeah, it did take quite some time, but hopefully this video is useful for you in the end. So yeah, again, like before, let's go ahead and make point dict, which is actually quite a simple function, but I thought it would be useful as a function because, it's kind of annoying to have to type it out again. So it's basically the opposite of before. So we're encoding the x and y values into something that can be stored in the JSON file. Okay, let's go back to save presets function. And again, looks like we have an issue with canvas mask. Oh, okay, I just closed this dictionary too quickly. I mean, not dictionary, the square bracket thing too quickly. And again, as you can see here, since these are single points, they're different from this one, which is a list, because canvas mask is, again, the freehand selection of a whole region. So yeah, next we can just write this into the JSON file. So to do this, we can do path.write text. Then do this. And yeah, there we go. And now we want to be able to load settings, which is different from load presets, because the presets and settings are two different things. Oops, type the slash there. So again, making sure we don't just stop when making sure we just don't stop when there's nothing existing. And again, this is going to be quite similar to our thing before. So basically, it's going to use defaults when settings.json does not exist as a file. So yeah, we're going to create settings.json later. So this basically just this line basically just copies only the recognized saved keys, which allows us basically ensures it allows, just basically just ensures that it ignores data from the older versions. And yep, we just return the build settings from the defaults, which are merged with the recognized saved values. Now we similarly need save settings, which again is similar to the ones for presets. And yeah, and with that, we can now move on to our planner, which is going to be another object. So class planner. And if you don't recall what the planner is, basically just converts the original image that we give it and its pixels into a preview of mouse instructions. So it doesn't actually do anything yet, but it plans out everything. And as you could see before in the demo video, you probably saw that it tells you how many keystrokes it's going to take, and um, if you click a button, it even draws out a demo thing for you. So that's what the planner is responsible for. So first, we need to do a few preparations, which we can do with prepare. And again, we have self, source, preset, and settings here. Oops. So basically, self is the planner itself performing the conversion, while source is the original pillow image chosen by the user. And again, by pillow image, I just mean the image is being handled by the pillow module. And it's the original one that you upload or take a screenshot of. And then preset is it basically just gives, it's a variable containing the canvas outline and the screen coordinates, while the settings is, well, the settings and everything we dealt with before. So with that, we can set distance to max 1, from 1 to, the maximum between 1 and settings.distance. So it's what the user sets, or 1, whichever one's bigger. So it can never be less than 1. And then the canvas width will be the maximum between 1, and then we need a more dynamic thing because it's well, here we're just gonna deal with a rectangle, but again, we can alternate between using a rectangle and having freehand control over the canvas. So this is gonna be the code for the rectangle. So we're basically rounding between the We're basically calculating an average between the bottom right and top left and dividing it by the distance. So let me just write it down so that you can see it better. Yep. So hopefully that makes sense now. I just said it in words, but perhaps that didn't make too much sense. We need to do a similar thing for height. And yep, I think that is indeed correct. Now we can get the image, which is going to be resized. And inside this, we're going to have source dot convert RGBA canvas width, canvas height, and settings. And it's basically just resize an RGBA copy of the source image to the sampled canvas dimensions using the resize mode that we had before, if you remember. And then we can replace the transparent pixels with the background color, white, as we had before over here. Transparent color. So let's just go ahead and do that. So image equals self.remove alpha image, and then settings dot transparent color. So that goes ahead and does that. And then palette equals self.palette image comma settings. So basically extracts the requested number of hex colors, and then image equals self.recolor image comma palette. So it replaces every original image's pixels with the nearest color palette color. And then, if you remember from before, we had that offset, which is basically calculating the screen offset that centers the prepared image, well, the original image, and then after we process, we have the prepared image, which we're going to be centering on the canvas. So we need canvas width, canvas height, image's width, the image's height, and distance. Next, we need to account for when it is a freehand selection. So active mask is going to be the name of our variable, and we can make that self.canvas mask image preset settings and offset. And what this does is that it converts the traced screen outline into a mask that can be matched with the prepared image. And then all we need to do is we need to just build the mouse actions, which are for the prepared pixels inside that active mask. So we can just do that with the following code. And this canvas mask image thing, you don't need to worry about too much right now because we're going to create that later. But for now, just you know what the function of it is, so we can leave it at that. And for this function, we just need to return draw a plan, image instructions, color order, palette, and offset. Yep, here we have it. So now we need to define remove alpha, which we used up here. So let's go ahead and do that. So again, this replaces transparent pixels with white because that's what our transparent color is. So RGBA can be equal to image.convert RGBA. And this basically receives RGBA and then returns a copy with 4 standard channels. And then we can do base equals image.new RGBA RGBA.size image color get RGB background plus 255 comma. So what this does, it creates an opaque RGBA background for the transparent pixel. And then next, we just need to place the RGBA source over the solid background and then return the RGB pixels. So to do that, all we need to do is return image.alpha composite base comma RGBA dot convert RGB. And yeah, there we have it. Now we can define resize, which I believe we also use. So resize is going to have a couple of different parameters. Self, again, image, width, height, and mode. And again, you know what self is, but image is, again, the prepared pillow image. Width and height are the sampled canvas dimensions. Mode chooses to, fit, stretch, or resize, but we're just going to have that fit all the time, so we don't need to worry too much about that. And then it's going to return an image that is ready for, to be, so basically after resizing the image, are we going to get the palette colors? So yeah, this is the first step before that. So what's returned from this function is what the palette decider thing uses to get the 12 colors, or how many ever the user has selected for the program to select. So mode is going to be mode.lower to make it all lowercase and ensure there's no capitalization issues. And if mode is none, then it keeps the original dimensions. And if the mode is stretch, which we can change, we can do a few things to stretch the image. And this code for stretching, I just borrowed from the internet from someone who already had it. So yeah, it's kind of just the way it is. There's not much to explain. It's just a good algorithm or code that gets stretching done properly. And then we can return soft dot and then resized thing. So basically expands the size into width and height arguments, which is quite useful for whichever wherever the resize is. And now you might have seen that we used this GIMP resize thing, and now we can define that. So define GIMP resize. And if you're wondering what that is, it basically resizes like the reference Drawbot's GIMP algorithm to preserve its image accuracy. And yeah, that's quite useful for our Drawbot. And we're going to have a few arguments in here. So self, image, target width, and target height, because we're resizing here. And I think these are quite intuitive in their names, so I'm going to skip over the explanation for this one. So, again, all of this that's going to come up here is again straight from the internet, because I can't be making resizing algorithms myself. So because this code has been pasted from the internet, I decided to save some time in this tutorial and paste it in from my original code. So I'll just scroll through this code very slowly, and you can copy it down, because I feel like there's not much to explain when I didn't really write this part of the code myself. So I'll close this too. And scroll. Yeah, feel free to pause the video anytime when you need more time to copy something down. I'll just scroll through this very slowly, because it basically just deals with the resizing and things, which I did not write myself. So yeah, also this GIMP interpolated line code, you can go ahead and just copy down, and I won't be speaking through any part of it. Feel free to pause anytime. So next we can move on to functions that don't need to be copy pasted. And for this one, we're going to be using static method. And as you saw before, all of the functions inside the class have self, but static method basically allows you to make a function that doesn't have self. So it's kind of not dependent on the class as much. So we're going to have this JS round function, which basically resizes the color channels while keeping it between 0 and 255, and value in this case is the channel number that's produced by the resize calculation. So this is just one line where we need to do this. Next, we have another static method for, so basically this matches the references resizer into, a 32-bit floating point number, and then value again is the Python number that should be resized to 32 bits, and then it just returns the 32-bit number. So yeah, basically just converts it into 32-bit. So here's where the struct module comes into play. And then we need the first item of this. Next, we have palette, which is again, not again, but this time is not a static method. And then we're going to have count. And wait, let me just pause and explain what palette is. So the palette function basically just extracts the short text palette that the executor, well, this is the planner, and then we're going to have an executor. So it extracts the short hex palette that the executor will enter into the game. And then here, self is the planner itself. Image is the variable containing the prepared RGB pixels, and settings is, from the settings that we had before. I don't think I need to explain that too much. So basically it keeps it to the requested maximum of 32, and then returns and then we have this median cut palette here being returned, which is basically receives the image and the count, and then returns its hex list. And as you can see here, we use the function median cut palette. So let's go ahead and define that now. Oops, clicked something again. So what median cut palette does is it reduces the original image's colors by splitting them into groups and then averaging each group. And this is kind of how image compression works as well. It just reduces the amount of colors by grouping them to similar colors together. And that's basically what median cut palette is going to do. And here are the arguments image and count. So the image is the prepared RGB pixels, and count is the maximum number of representative colors to return. So when it's 12, it's going to be 12. Now we have this empty bins thing, which basically merges very similar colors early, and then this basically makes later calculations much faster, even though it's not what we're going to be using in the end. So I wasn't too familiar with how to use this as well, but basically this deals with Pillow to provide flattened data directly and then older versions use get data, so it basically accounts for that. So now we're shifting by 3 groups, and each channel becomes 32 instead of 256. So RGB is usually out of 256, but now we're getting it to 32. And now we can create something called bucket, which is going to retrieve or basically create the color's bin count and channel totals. And then this is going to be useful later, which I'm going to explain why in a moment. Now we're going to be converting every non-empty bin into an average color and then add its population, which is basically how many of it there are. And then if there are no entries, we want to make sure our program doesn't just fail. So we can account that by doing if not entries, we can return just black. And now we want to begin with one box which has all the entries, now that we've dealt with there being no entries. So boxes equals entries, and we can have that as a list. And now we can repeatedly split the most useful box until we get the requested count. So we can do that with a while loop. And then we need to be able to remember the best split, because again, we're in a while loop right now, so we can do split index equals -1 at the start, and then split channel to R, and then best score to -1. And then now we need to check every single box as something that can be potentially divided. So for index box in enumerate boxes, we're gonna check for if a box, because a box with one entry can't be divided any further. So we need to do if len box is less than 2. Then we continue. And we also need to measure how much red, green, and blue, vary inside this box, right? So that we can have ranges which can do this. And now we can pick the channel which has the largest spread. So we can first set channel to R. Then for so we have these. We have R for now, and then we check G and B. So for a candidate, we can just name a candidate in G and B. If range is candidate is greater than range is channel, then we set channel to candidate. And we also need to favor the boxes that are both varied and also common in the image. That's how we get to the color palette. So let's have population as a variable. So this is entry count for entry in box. And then score can be ranges channel times population. And then it saves this candidate whenever it beats the earlier score. So that's pretty simple. If score is greater than best score, we split index. Best score is -1 by default, so that takes care of any issues, because it's always going to be greater. I keep typing index error. That is annoying. There we go. And well, we need to get out of this loop, so when you can no longer divide a box, we can break. And now we can sort the chosen box along with we can sort the chosen color box along the channel with the widest range. So that basically just means that we are getting to normalizing the colors within the image. So this next total thing basically just finds the point that places roughly half of the original image's pixels on each side. And now we can test these split points while keeping at least one color on each side. Oops. Just clicked something there. And finally, we can replace the original box with the two new halves. So we can just do that with boxes and then split index to split index plus 1 with box cut, then box cut. Oops, I should go in the end. That's how we get the split. And then finally, we can turn every final box into one hex color. So we can have palette. Okay, we don't need this here anymore. We can have palette as an empty list, and for box in boxes, we can have population equal to the average of how often each binned color has appeared. So basically, and then RGB can be tuple, round, and then sum, entry channel, oops, times entry count for entry in box. And this can be done for all three channels, RG and B. I believe we are, yeah, we're okay there. I think that should go in here. Yep, I think that sorts things out. And then we can finally format the three channel numbers RG and B into standard hex text. So you can go ahead and do that like this. Dot format RGB. And we also need to avoid duplicate color changes in case two boxes average to the same value. So in order to do that, we can just stick to a simple if statement. If color not in palette, then palette dot append color. So basically append receives color as its one argument and then adds that hex string into the palette. And finally, we can return palette. Yeah, that is quite a big chunk of our program because that's how we determine the palette of colors that substitute the colors actually used in the original image. Now we can work on actually recoloring every pixel that the game will use. So that define recolor, then self image, and palette. So we know what self is, and image is basically variable containing the RGB pixels that need to be replaced, and palette lists the hex values that are allowed in the result. I think the spelling is two T's. So yeah. Now we can convert each palette hex string into, it's each component, R, G, and B. So we can start off by just doing that. Now image.new is going to receive RGB and image size, which can then return a blank same sized output image. So let me just write that down first. So output image.new RGB image.size. Then we have source pixels, which is of the original image, which is just image.load, and then output pixels, which is going to be output.load. Then to remember the answers for repeated source colors and to avoid repeated searches, we're going to have this little cache. And then we can finally visit every original image's pixel now. So for y in range image.height, and also for x in range image.width. Oops. We can look up whether the exact RGB color was already matched earlier. So to do that, we can just do source equals source pixels x comma y, and then nearest equals to cache dot get source. And then if it's not, then we can compare it with every palette color and then keep the closest one. So if nearest is empty, so if nearest is none, then we can select the palette color with the smallest RGB distance from the source. So to do that, we can do nearest equals minimum palette RGB, and then get the minimum distance. We can do that with the help of a lambda. Color distance from before source comma color, and then cache source equals nearest. And we can write this selected palette color into the same input position. So we can do output pixels x comma y equals nearest. And finally, we can also return output here, which returns the fully color reduced image. Now we can define the offset function, which we used earlier. So offset, to remind you, decides where the image sits, because fit mode is going to, which is set by default, is going to leave some unused canvas space. Not always, but when it does, we need to kind of account for that. So let's go ahead and do that. Offset can have self, canvas width, canvas height, image width, image height, and distance. So again, you know what self is, but canvas width and canvas height are the sampled game canvas width and height. Image width and image height are the width and height of the actual original source image. And distance converts the sampled pixels into pixel screen spacing. And so yeah, the return point is going to be added to every planned screen coordinate now. So we can first calculate how much of the horizontal and vertical space is unused separately. So x space is the maximum between 0 and canvas width minus image width times distance. And similarly, y space is going to be for canvas, height and image height. And now half of the unused space centers can be taken so that it's basically centered. So x equals x space divided by 2, y equals y space divided by 2. And then now we can return the centered offset. So yeah, that takes care of any unused canvas space that might be there. Now we can, if you remember, there was a section where it showed you how many strokes it will take and all that, and that is quite useful for the program as well. So it's basically going to count the mask colors, order them by region size, and then finally plan out all the mouse instructions that the executor is later going to perform. So we can define instructions with self, image, preset, settings, offset, and active mask. And I hope these names are familiar to you by now, but image is the palette reduced pixels in this case. Preset and settings are the stuff we had before, and offset is what we just had, and active mask is the traced canvas. So first we can load the pixels for to work on it. So pixels equals image.load. And then also the pixels for the mask, which is the freehand selected region of the canvas. So active mask.load. But then we also need to account for if it might not be there. So if active mask is not none, else none. So that takes care of that. And now we need a counter which can track how many paintable pixels use each color. So count, this can be counter. And now we can scan every single prepared pixel to count the colors inside the traced canvas. So again, we can kind of go in a for loop for y and x, so for y in range image dot height, and for x in range image dot width. We can first be able to skip the pixels that are not in the user's canvas outline to avoid start painting outside the canvas, because that's just going to waste time and it's quite useless. So if mask pixels is not none and not mask pixels x and y, we continue. And then we need to turn the pixels RGB values into the same hex format used everywhere else. So again, this is going to look familiar, but we just need to do that. Dot format pixels x comma y. And now we can increase the color count by 1. So counts color plus equals 1. And now we can paint small color regions first and then large color regions last. So to do that, let's have colors, and then let's just make this a list comprehension to save time and space. I in sorted counts.items key equals lambda item, and the second item. So basically, just to repeat myself, this is going to paint small color regions first and large color regions last. And now we can finally have an instructions list and add to it. So we can do this for every color in our colors list that we just created. So from iterating through this colors list, we can add to instructions. So for a color in colors, we can add the entire thing to instructions. So instructions.extend self.color instructions image color preset settings offset and active mask. And then we can return instructions and colors. And you might have noticed here we have this new thing, colors instructions, and that's what we are going to be coding next. But then also colors instructions is responsible for grouping neighboring pixels of one color into safe, faster drawing instructions. So I just read that off a GitHub page that I used to have this done because I wasn't too sure of how to do it myself, and also people have done it in the past. So yeah, I think this part again is best to just copy and paste. So yeah, I've got color instructions pasted in now because again, it's not my code, and I'll just scroll slowly down while you can copy this piece of code. Feel free to pause anytime. And again, over here we have drag. This is a piece of editing I did to support drag, and it basically just allows for drag mode, which is another type of stroke that our program does. But the rest of the code was taken from the internet and just adapted to fit our code. So I won't be explaining it much since it is not mine, and also it's just things that people have done in the past to get good results, which we need not bother ourselves much with because they've already done the refinements there. So after you've copied this down, our next step is going to be to count an undrawn same color horizontal run without crossing the canvas mask. So basically, it's like a section of drawing the entire thing while going in individual horizontal runs. So if you saw the drawing tool in the Drawbot in action in the video, you'd see that it goes in rows and then moves down. So that's what we're kind of going to be coding in this function. So def run, and then we can have self image drawn x y color and active mask. Just to clarify what these are again, image and color identify matching pixels, and then x and y identify the first pixel in the run. An active mask is, again, the canvas that the user traces before. So first, we just need to prepare the quick access to the source pixels, which is original images pixels, and then the optional mask or the rectangle. So since for this one, we don't have a rectangle, instead we have a mask, we always have this mask thing going on. So pixels equals image.load, and then we can have mask pixels equal active dot mask dot load. And then since we also have the rectangle option, which right now we're not going to have it as an option in our code, but then if you ever want it as a rectangle instead of a freehand crop, you can add this if active mask is not none, else none. So it also works if we in the future decide to make it a rectangle instead. And now we can first begin with a length of 0, because it hasn't gone any distance yet, and then it's going to grow 1 pixel at a time. And then while true, so we have this while true because we're going to continue until a boundary or a non-matching pixel ends the run. So basically it's going in horizontal stripes across the cutout that we've traced out with our mouse. So we can have px equal x plus length. And then if px is more than or equal to image.width, then we can return length. So it's going to stop right at the image's edge. And it should also stop at a pixel that's already covered. So if it's already painted, or the masked boundary, or if the color changes, because we don't want to be coloring 2 times, because that's just going to waste time. So if then we can have kind of a long if statement to account for all of these situations. So if px comma y is in drawn, which is the list, or mask pixels is not none, and not mask pixels px comma y, or pixels px comma y is not equal to color, then we return length. And then at the end of all this, we want to increase length by 1. So yeah, that is it for run. And now we can have a function called absolute point. And what this is going to do is it's going to work in small image coordinates, because the whole thing, when we have the execute, we're going to have full screen coordinates, but then planning works in smaller image coordinates than actual. So this is going to account for that. So we're going to have self x y preset settings, and offset. So I think preset settings and offset I've already explained before, but not X and Y in this case are just the coordinates inside the prepared image. And now we can combine the canvas origin, the centered offset, and also a sample spacing into the screen point. So we can return point and then preset dot top left dot x plus offset dot x plus x times settings dot distance, comma, preset dot top left dot y plus offset dot y plus y times settings distance. And yeah, that's it. Now we're finally going to define canvas masked image, which basically converts the traced canvas outline into a pixel form, which can be used for all the Drawbot planning stuff. So we've already used this function, but we're yet to define it. So we can finally do that over here. So define canvas mask image, and we can have self, image, preset, settings, and offset. And over here, image is basically what supplies the mask dimensions. And fewer than 3 points can't form a closed area, so it always uses a rectangle. And to ensure this, we can do if len preset dot canvas mask is less than 3, and it returns none. And also, we're gonna have this to return a black mask, and we're going to set distance to the maximum between 1 or the distance in the setting, so it always keeps it. We already had this code before, but yeah. Now we can translate every trace screen point into something that's relative to the image's origin and scale. And to do that, we can have polygon, which is just going to be equal to round. Perhaps it's going to be a bit long, so it might be a good idea to have it in separate lines. Let me do that again. And then we can have round point dot x minus preset dot top left dot x minus offset dot x divided by distance. And then similarly for y. So I'll just change this to y. And then this is 4 point in preset dot canvas mask. Next, we can fill the traced canvas shape white in the planning masks. So basically we had that as black, and then now we fill it as white. So image draw mask dot polygon comma fill equals 255, which is white. And then we can return the mask. And with that, we're done with the planner, and we can move on to the executor, which sends the completed draw plan to Windows as a mouse and keyboard input. So let's have another object, class executor. And within this, we can def init, and we need self, stop event, and a status, which we can set to none for now. And to explain, you know what self is by now. Stop event is set when the interface or a stop hotkey, which cancels the drawing, which we're going to incorporate later. And also status receives progress text or defaults to a function that ignores it. So basically, if there's any function that ignores a progress text, then that's what status receives. So we're gonna store the event so every loop can react to the stop button, which in our case is going to be either escape or Q. You can make it either or both. I'm going to have it as both. So self.stop event equals stop event, and self.status equals status, or lambda message none. Next, we can make an execute function, which basically walks through the full plan in order and changes color when needed. So we can have execute with self, plan, preset, and settings. And then all of these arguments should be quite intuitive. Plan contains the ordered drawing instructions. So we can have last color set to none as at first, because no color has been entered into the game yet when the code is first run. And then we need to save the total once, so progress messages don't repeatedly recount the list. So we can go ahead and do that. And now we can do for index instruction in enumerate plan dot instructions, comma, start equals 1. And here enumerate basically provides each instruction, and also to make counting more intuitive, I think start equals 1 makes that good. And we want to stop when escape or Q has been pressed. So if self dot should stop, which we're going to define later, and self dot status, and then we can have stopped at index, comma, divided by, I mean, it's not a divided by, it's just a slash that the thing's going to see. So basically, if you stop the program at 3,600 brush strokes and the total is 4,000, it's going to stay stopped at 3,600 out of 4,000. So it knows how far into the drawing the program got before stopping. And also, we need to enter a new hex value only when the instruction is different from the last color. So if instruction.color is not last color, then we need to enter the instruction's color through the calibrated hex field we had earlier. So self.setColor instructions.color preset settings. And then last color can be set to instructions.color. And then now we can execute this instruction with the configured brush timings, which the timings are within the settings that we can later control in the UI. So self.execute instructions, instruction, comma, settings. And now we just need to update the interface after every action and also after every 100 actions. So we can do that. In the self.status, drawing index divided by, or out of, total. So this basically ensures that it isn't a rapidly increasing number, but it updates every 100 actions. And then we need to tell the user when it's done drawing. So it's going to be outside of this for loop and be self.status f-string done, and then drew total instructions. There we go. And now we need to define the function setColor, which basically it's gonna allow for color selection and of the calibrated hex values and also the requested hex value. So it's gonna make a bit more sense after you write it down. So def setColor, self color preset and settings. So here, color is the hex value to be entered. Then self.set hex color preset the hex input color, and self.sleep settings.delay ms plus settings.color delay ms. So this brings that gap between keystrokes that ensures the keystrokes are actually registered instead of it being way too fast for it to register. And now, before we used execute instructions over here, so we need to define that as well. So this execute instructions is what's gonna execute the dot, run, and drag, which are the different type of brush strokes, and it's gonna do so with the configured delays in settings. So we need self instruction and settings, and if instruction.kind equals dot, then it's going to self.move instruction.points and self.click settings.move delay ms and self.sleep settings.delay ms. And then it's not going to return anything. And then if it's .run, which basically clicks rapidly, unlike dot, which clicks one point and then waits, and then clicks one point and then waits. So if instruction.kind is dot run, then it is going to do this in bursts. So we're going to have burst delay as the maximum between 1 and settings dot delay ms and settings dot move delay ms. And it's going to visit each point in the horizontal runs that we have. So for index comma point and enumerate instruction dot points. It's going to move to the run. It's going to move to the point and then make a bunch of brush clicks. So self.move point and then self.click. And then it needs to pause every 5 marks to help the game, to ensure the game registers all the clicks. So if index plus 1 divided by 5 and its remainder is 0, and so this basically ensures it's a multiple of 5, so it makes the pause every 5 marks, and also make sure it's not already done. Then it's gonna sleep for burst delay amount of time. And then in the end, we need the normal delay stuff that's always there, which is just settings dot delay ms. Nothing returned again. And now, outside of these if statements, we need to account for drag, which is the third and final method of brush strokes. And for this, we need a start and an end, which is going to be instruction.points, and then self.move start, because drag is kind of the default for us. And then this is where we deal with the mouse. So again, I needed to refer to official documentation because I didn't know how to deal with mouse stroke stuff. And then self.sleep settings.move delay ms. And then we go to the end. So it basically has the mouse clicked and then goes to the end for a setting. Well, we have settings for how long it should take to move, which is move delay ms, and then it stops clicking. So basically this, but instead of having left click, we press down. We want to bring it back up so it stops clicking. So that kind of creates that smooth brush stroke, which is a drag in our case. Self.sleep settings.delay ms. And this is our default method of brush strokes, but you can switch to dot or dot run if you find that drag does not work. Now we want to stop the UI and also just stop clicking everything when we press escape or Q. In my case, you can have it as either escape or Q or both. In my case, it's going to be both, just because I feel like sometimes when you press escape, in the case of Roblox, the menu thing pops up, so I have Q as well for that reason. So when we have should stop, then it's going to return self.stop event is set, or so I'll explain in a second what's going on here. So this get async key state thing over here basically um, means that the key is already held down, so it checks for that and then stops action. Now we use things like move and click as functions, so we will need to define those as well. So we just need self and point here, with point being the exact screen coordinate of the next brush action. And then we will be using this a lot, so probably nice to have that copied now. And we want to set our cursor position to the x and y values of point. So that takes care of that. And then we want one fixed motion, because often games don't register if it's too much of a rapid burst. So we'll be using things like time.sleep here now. So again, some of the syntax I needed to refer to a documentation for, because I wasn't very familiar with it. And now we can move one cursor back to, one pixel back, so that the cursor is at the planned coordinate. And now we can sleep once again for the same amount of time, which is basically just means wait once again for 0.004 seconds. Now we can define, I wonder why this is. Let me just take a look at this for a second. We can clean this up. I will get back to it later, but for now, we can continue. Ooh, okay, this is not indented for some reason. Alright, so now we need click. And for this, we just need self and hold MS, with hold MS being the number of milliseconds that the brush should remain pressed. So, okay, that is close to what we want. And then we just wait for hold MS amount of seconds, which is going to be milliseconds, as you can tell by the MS in the name. And then, right, we don't need the 1 there. And here we have left up, so stops pressing. And again, we need indentation here. I'll revisit the errors that pop up. So now we need set hex color, which we used before, which basically replaces the game's hex field text and submits the new color. So as you can see in our demo video, it basically just clicks on the field where you can enter hex and then pastes in and then presses enter. So yeah, that's just, again, just a series of steps that we need to do. So we just need point and color, because we need to set the hex color in there. So we need to move to the point, and then we just need wait times to make sure everything registers. And then for I in range 2, just to repeat twice, we want to click and then do that. And it's always nice to click multiple times to ensure it works and doesn't fail, especially because everything's happening in such a fast pace. And just because why not? You know, the computer can do things pretty fast. And then we're just gonna press Control A to select everything that's already in the hex field. So we want to press Control and also A. And then we just need a lot of these rest times, which the wait time's quite arbitrary, but I just played around with stuff and tried to stay safe to make sure everything works. And then we need another thing called tap scan, which we're gonna define in just a second here, but we're gonna press backspace and time.sleep 0.08. The reason we need tap scan is because it often doesn't work, and to make things more foolproof, tap scan is better. I'll get back to tap scan in a sec. Well, let's just finish this algorithm. So we just need to type the color now in hex. So since color is already in hex, we just need to make sure it's uppercase like the game wants. And then a couple more wait times, so sleep. And then again, a tap scan to press enter, because again, enter often isn't recognized by the game. So yeah, we can define tap scan now. And tap scan basically, what tap scan does is press the key and then wait a bit and then releases it. So it kind of presses for longer, make sure it really registers, because when you're doing things so fast, and perhaps your game is a bit laggy, it is quite likely that actions are going to fail. So yeah, tap scan basically is something that I added when things weren't working for me. And here, it's a keyboard event. So keyboard event. And then we need to do that. Alright, I didn't explain what scan code and delay are. So scan code basically identifies the physical key, while delay is the number of seconds that the key needs to be remained pressed. So after we sleep, by sleep, of course, wait for that many amount of seconds, we just need to let go. So we just add that. And yeah, I just realized that isn't indented. Yeah, things aren't indenting. Perhaps it's because of the errors. I'm not too sure, but make sure things are indenting for you. Okay, that's fine. All right. We do have one more function called scan hotkey. And what this basically does is hold the key and then tap the key by its scan code and then release it. So it's going to make a bit more sense when we write it down. So we have modifier here, which is basically the two physical key scan codes. And then we're gonna sleep for delay amount of seconds. And delay here, by the way, is just how long the main keys remain pressed. So yeah, now we have tap scan, which receives key as the main physical key, and delay as its held duration. And now we just need to release it. So again, I think we can just go ahead and change this to modifier and then get this. And we should be good there. So now we want to be able to type the hex characters, and because we are using this new system of ctypes.windll user 32, I did not use the keyboard module like last time, but I think this one might be a bit more reliable as well because it's a bit more direct with how it interacts with Windows. So yeah, I think this is a good evolution from our last programs, although I believe that the last programs that I've had are a bit more understandable as to what's going on. So we have this for loop to be able to type each character at a time so that the game, can actually register what's going on. Otherwise, if we just press all the keys at once, that's not going to work, obviously. So yeah, we basically just type out the letters of the hex. So again, I had to search up how to use this new thing because last time I was working with the keyboard module. So these are just some syntactical stuff. And then if key data is -1, which means that the active keyboard layout cannot produce the character, and then it's going to raise an error because, it's unlikely that that happens, but it just accounts for that error. And then we're going to store the keys. So to do that, we can have virtual key as key data and that, and then modifier state as key data. And it's going to collect all these modifier keys that are required for the character. So it is a bit more complex and tedious. I did just copy from the documentation of how to use this new thing because I think it's a bit more complicated compared to using the keyboard module which is a bit more straightforward. So yeah, I'm just gonna type this in without talking too much because it is a copy of the code from documentation. Just realized it isn't indenting again, so I'll go ahead and do that. So yeah, hopefully you've got that down now. And now we need a static method, which basically just we use sleep, but we didn't do time.sleep because the time module expects that the durations are in seconds, but then here we're working with milliseconds. So we're gonna have that conversion now. Yep, there we have it. We just converted seconds into milliseconds. And yeah, that is actually it for our drawbot.py file. Now it did identify a couple of errors, so I think it's a good idea to go back and look at what might have gone wrong. And right away, I think top left should have this over here, and that should be okay now. And now I think we need to make this frozen so that it doesn't change, which we missed out on earlier. And I think this was a mistake. I don't know why I just set it to 1. Yeah, it should add 1 to the total, which makes much more sense. And then I think it should be presets over here. That makes much more sense. We didn't have preset before, so. And I believe that I misspelled that, so let me go ahead and do that. And okay, canvas height should use y coordinates, which I have forgotten to change. Oh yeah. Missed the T there, of course. Ooh, okay. I think I see what's going on. These should go in here, and that fixes everything. Okay. So just an indentation issue. Oh, okay, I forgot to close this bracket. We were adding the tuples incorrectly. I think that should be good now. Oh yeah, I think these are pointing in the wrong direction actually. Because when you're doing a median cut palette, it should be the opposite direction. And I think we need to divide this by population, which we missed out on. And then, okay, here we just overwrite the thing, but we need to make this output pixels. Oh, these are inside the define, which does not make sense. Go ahead and bring all of these back a step. There we go. Oh yeah, and this should be mask and not active mask. Yeah, executor. That should be executor. And I think it should be singular. And this should be singular as well. It just keeps things consistent because Plural doesn't really make sense in that context. And I think this is... Oh yeah, it should be a colon and not a semicolon. And drew that many instructions. Just an English error. And then I think it's the indentation here, isn't it? Or no, we're inside this, so we need to... This is what's indented a bit too much. And yeah, I think we're missing something here. We need a for loop to check for modifier key release loops. So we need for modifier and reversed modifiers. C types dot window dot user 32 dot keybind event modifier 0. There we go. I think that's what we were missing from the code before. And also, yeah, I think that's about it. I just spotted another English error. That should not matter, but let's just fix it since we spotted it. Yeah, I think that should be the fix. There are no more red underlined spots. So yeah, that seems pretty good. And that will be the end of part 1. And part 2 will, I promise, be more exciting because we can actually see something like a user interface. All of this stuff is just logic, and we don't really get to see anything actually happen here. If you run the code, nothing's gonna happen because it's all just, functions and stuff, and we never really call any of it. So yeah, please stay tuned for part 2, and well, just check it out immediately after if you're feeling like it, or take a break and then go to it, and I'll see you in the next one.